Okay, hello everyone. So we have already covered Biot-Savart law. The next important is Ampere-Circuital law. So with this law, you can even find value of magnetic field, and you can also find what is the current in and or around the loop. So how to use this law? Let's first discuss the statement. So this law states that line integral of magnetic field over a closed loop is equal to the product of the current enclosed by the loop and permeability of medium. So what is the meaning of line integral? Suppose we have a closed loop, the blue color shown in figure. Line integral means the dot product of magnetic field and length vector. So suppose at this point length vector is dl1, magnetic field is b1. So line integral for the small length will be b1 dot dl1. Similarly, for the small length dl2, line integral will be b2 dot dl2. Similarly, for the small length dl3, line integral will be b3 dot dl3. So if you take small length on the full loop, suppose I take small length here, then small length here, then small length here, then small length here. So if I'll add all this line integrals, if I'll add all this line integral, then it can be written as integration of b dot dl, and this circle will represent that we have covered the full loop. So this circle here represents that we are talking about a closed loop and integration of b dot dl. So this full statement, this full mathematical statement is called as line integral of magnetic field over a closed loop. So line integral of magnetic field over a closed loop will be mu naught times current enclosed by the loop. So now we'll discuss what is the meaning of current enclosed. Suppose we have a closed loop and a current of 2 ampere is going like this and a current of 6 ampere is going like this, and there is a current of 8 ampere outside the loop. So if I have to calculate the line integral of magnetic field over this loop, then integration of b dot dl will be mu naught times current enclosed. But remember, the current which is upward direction is taken as positive, so plus 2, and the downward direction is taken as negative, so minus 6. So answer will be minus 4 mu naught. So line integral of magnetic field over this closed loop will be equal to minus 4 mu naught. So this is how you have to calculate the line integral when currents are given. You don't have to consider this 8 ampere because this 8 ampere is outside the loop. Okay, so if someone asks you, with the help of Ampere circuital law, can we find out the value of line integral? Yes. Can we find out the value of magnetic field at all the points? Suppose if I ask you that find value of magnetic field at this point. So it is not possible with the help of Ampere circuital law. We'll need something else also. So you have to learn how to use Ampere circuital law. Okay. Now in this question, so magnetic field B is given and there's a square loop A, B, C, D, A of side length L, and you have to find out what is the current enclosed by this loop. So what we'll do is you to find current enclosed by loop A, B, C, D, A. So what you have to do is just see. So for a closed loop, so from A to A, integration of B dot dl will be equal to mu naught I enclosed. So I have to move from A to A, so I'll break the path. So I'll go from A to B, from B to C, from C to D, and from D to A, equal to mu naught I enclosed. Now if we'll see, from A to B, magnetic field is in this direction and length vector is from A to B. So B dot dl will be B into L because cos 0 will be 1. If you'll see, from B to C, from B to C, length vector is in this direction, magnetic field is in this direction. So angle is 90 and cos 90 will be 0, so this will be 0. Similarly, from D to A also, length vector will be in this direction, magnetic field in this direction, angle is 90. So from D to A also will be equal to 0. And from C to D, length vector is in this direction, magnetic field is in this direction. So I have put minus. So BL minus PL equal to mu naught I enclosed. So current enclosed will come out to be equal to 0. So this is how you have to use Ampere Circuital law to find, if you can find line integral and you can find current enclosed by a loop. Okay, so if you have any doubt, you can WhatsApp me, but please note down this statement and these two very important examples of Ampere Circuital law.